This is the video solutions for questions 1 through 6 that you were assigned to complete Tuesday, May 28th. I'm going to go into some detail with these, so please make sure you follow along. Even if you got the answer correct, it's still good to make sure that you know how to solve it, even if it weren't multiple choice, if it were long answer. And I'll try to point out some different details as we go. So question 1, there's a lot of reading in this. They talk about a distance of an object. It can be modeled by this equation right here. They tell us what A is, what T is. And then the question is here, what is T in terms of A and D? So I'm trying to get T alone. So I'm going to rewrite this out over here. D equals 1/2 times A times T squared. First thing I want to get rid of is that 1/2. Anytime you've got a fraction. So I'm going to multiply both sides by the denominator. Those are gone. So I get 2D equals A times T squared. Remember, I'm trying to get T alone. So to break apart multiplication, I'm going to divide both sides by A. So I get 2D over A equals T squared. And then to get rid of the squared, the opposite of squaring something is square rooting. And when we physically write a square root, I have been telling you, please remember to physically write a plus and minus. Now, that answer does not show up with a plus or minus. The closest I get is here, answer choice 2. And the reason is, it says T is the amount of time the object has fallen. It wouldn't make sense to have negative time in this situation, so we would only consider the positive square root, which means it's just the square root of 2D over A. Question 2. Solve the inequality below to determine and state the smallest possible value for X in the solution set. Since it's an inequality, I want to remember to flip the sign if we multiply or divide by a negative number. So the first thing I notice is I've got parentheses. I'm going to go ahead and distribute that 3 through. So that's going to become 3x plus 9 is less than or equal to 5x minus 3. For me personally, I like to get my x's on the left. So I'm going to subtract 5x from both sides. So that'll give me negative 2x plus 9 is less than or equal to negative 3. Watch those signs. Then I'm going to subtract 9 from both sides. So I get negative 2x is less than or equal to negative 12. And finally, to get x alone, I divide both sides by negative 2. And because I divided by a negative, I'm going to flip that inequality sign. I'm going to bring this x straight down. I'm going to figure out what negative 12 divided by negative 2 is, and that is 6. And this is my solution to my inequality. When I go back up and reread the problem, it says solve the inequality below, which I did. My solution is right here. But then it says determine and state the smallest possible value for x. Well, if I graph this, my boundary is 6. And because there's a line underneath the inequality, I want to use a closed circle at 6. This says x is greater than or equal to 6, which means I'm going to shade up and to the right. So what is the smallest possible value of x in the solution set? It is 6. Now, I want you to be careful because let's say we solved it and we got this. X is greater than 6. How would this be different? Well, now 6 is going to have an open circle, and I'm going to shade above. In this case, they wouldn't ask you for the smallest possible value. They would ask you, what is the smallest integer that would be a solution? And the smallest integer that would be a solution in this case is 7. Because 6 has an open circle, it's not part of the solution. We could include it here because it was X had to be greater than or equal to 6. So it was a filled in circle. One other piece with this, if I had to write this solution in interval notation, it starts at 6 and it goes to infinity. And I would put a square bracket at 6 because it equals, it includes that the actual value at the boundary. If I were going to write my solution set for this interval, it would be 6 to infinity, but I would use a parenthesis at 6 because it's an open circle. Number 3, what is the solution set of this equation? So let's do this 2 ways. Remember when we're solving this, this is a quadratic equation, so I could solve it graphically. I could factor t-chart solve. I could complete the square, or I can use the quadratic formula. So I'm looking for where this is equal to 0. I'm going to do this graphically. So I'm going to add a page, add a graph, and I'm going to type in this left-hand side of my equation. X squared plus 11x plus 28, and then I'm going to graph that. So what I notice when I graph this on my calculator is that my graph is over here. Where is this function equal to 0? Well, it's equal to 0 here and here. And I want to know where those are. So if I go menu, trace, graph trace, I can go ahead and start moving along this graph. And right there, I get my first 0, which is at -4. And if I keep going, there's my vertex. There's my second 0 at -7. So I know my solutions are -7 and -4. Now, if they said you had to solve this algebraically, you could not do it this way. So let's try factor t-chart solve. So it's equal to 0, so I'm good to factor this. I multiply these two together, and I figure out what are factors of 28. So that would be 1x and 28x, 2x and 14x. 3 does not go into 28. 4x and 7x. Oh, and there it is. 4 plus 7 is 11. So I'm going to use 4x here and 7x here. So this factors into x plus 4 times x plus 7. And now I can set up my t-chart. I'm going to subtract 4 from both sides. So my first solution is x equals -4. Subtract 7 from both sides. And my second solution is x equals -7. So that matches with what I got graphically. Okay, number 4, factor completely. When they say completely, this means you're going to do more than one step. So your very first step is to check for a GCF. Second step is to check the number of terms. If there are 2 terms, it might be a difference of two perfect squares, in which case it's going to factor into a plus b times a minus b. If it is 3 terms, we have to set up our area model to factor it. So let's look at this problem. What I notice is that both of these terms contain an x. So I think there's a GCF of x. I don't think there's any number that divides 4 and 49 evenly. So I'm going to just take an x out. Remember, when we pull a GCF out, it's like we're dividing. So for this 4x to the third over x, this x and this x will cancel. So I have 4x squared minus, and then the 49x, that x in the top will cancel with the x in the bottom. So I've pulled my GCF out. Now down here is where I'm going to write my answer. And I want to do this because it's very common to forget the GCF. So I'm carrying my GCF right down. Now I'm going to look at what's left. There's 2 terms left. So the question is this a difference of 2 squares? Well, if I square 2x, I'll get 4x squared. So that looks good. And 49, if I square 7, I'll get 49. So this is a difference of 2 perfect squares. So I set up my 2 parentheses. 2x and 7 goes into each of those. 1 gets a plus, 1 gets a minus. And now I just add this to my answer. If you would like to know if you got it correct, you can graph the original problem. So I'm going to graph 4x to the third minus 49x. And then I'm going to graph my answer. So x times 2x plus 7 times 2x minus 7. And if I hit enter, I see they line right up. So that tells me at least that my answer is equivalent to what I started with. It won't necessarily tell you if you graphed it or factored it completely. Because, for example, if I put in this, my second answer, if I put this answer into a graph, what you'll notice, invalid input. Oh, I know, I'm missing my multiplication here. You'll notice that it also lines up. So it can't tell you if you factored it completely, but the calculator can verify that what you have is equivalent to what you started with. Okay, 5. This is a good word problem. A fence was installed around the edge of a rectangular garden. Draw that picture. And since we're installing a fence around the edge, I'm going to go ahead and label all 4 sides. They didn't talk about the area. They just told me the fence went around the edge. The length of the fence was, so I'm going to go ahead and write L equals 5 feet less than, so I've got to do minus 5. 5 less than what? Well, it says 3 times the width, so that would be 3W. The amount of fencing used was 90, so 90 would equal, how would I figure out the fencing? Well, I'd have to add up all of these sides. So when I add those sides up, I'm going to have 2 L's plus 2 W's. So it says write a system of equations, which I did, or write an equation using one variable that models this situation. So here I have a system. The second part says determine algebraically the dimensions of the garden in feet. So dimensions mean length and width. So I need to find both of those. So I know L equals 3W minus 5. That's from above. And I know 90 equals 2L plus 2W. Since L is by itself in my top equation, I'm going to substitute that quantity in. So I'm going to have 90 equals 2 times L plus 2 times W. But I'm going to replace L with 3W minus 5. And now I can solve this. So I'm going to go ahead and distribute that 2. I notice I've got like terms on the same side, so I'm going to go ahead and combine those. 6 plus 2 is 8 W's. I want to get W by itself, so I'm going to go ahead and add 10 to both sides. And that gives me 100 equals 8W. So to get W alone, I'm going to divide both sides by 8. And I know it doesn't go in evenly, so I'm going to do 100 divided by 8, and I'm going to hit Control Enter. That gives me 12.5. So there's my width, and it makes sense. I can have a width of 12.5 feet. So I found my W. When I go back up, I notice, oops, I still need to find L. So L is going to equal 3 times W minus 5. And we found that W is 12.5. So to find my length, I'm going to go ahead and just type this in. And I get 32.5 feet. So I found my length, I found my width. It says determine algebraically the dimensions. I notice it says in feet, so I just want to go back and make sure that that 90 was feet, and it was. So everything I'm solving for is feet, and we are good to go. Last problem for today. They say graph the system of inequalities in the set of axes below. So I'm going to go ahead and open a graphs page. Because y is not alone, and because this is an inequality, I'm going to plot this as a relation. So I have 3y minus 9 is less than or equal to 12. Now, this is interesting because there's no x in there, but that's okay. I'm still going to be able to graph this. Now, when we look at this, you're going to notice the whole screen is blue, but don't be alarmed. Trace your function. So I'm going to go to Menu, Trace, Graph Trace, and it pops me up to my y-intercept, which is 7. 1, 2, 3, 4, 5, 6, 7. So I notice that I'm at 7. I also notice that this is a solid line up here. So I know that I want to draw a horizontal line straight across. And I don't want to forget to sign the line. So 3y minus 9 is less than or equal to 12. And I know I'm going to be shading below. I'm going to save that shading for at the end so I don't get all my shading confused. So this was a solid line. This, because this is just less than, not less than or equal to, this needs to be a dotted line. So I do not want to forget that. I'm going to hit tab. I'm going to type in my second equation. So y is less than negative 2x minus 4. And if I hit enter, I get my second inequality. Now, when I look at this, if I hover over it, I can see it's a dotted line. But if you weren't hovering over it, it would be hard to tell. So it's good to keep in mind, think through all those details as you're working on this. So I'm going to go ahead and trace this. Now, right now I'm on the blue line. To jump to a different line, you can hit the up or the down arrow. So now I can see I'm on my red relation. So 0, negative 4 is my first point. Then I'm going to type in 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, I get 1, -6. Then I can type in 2. I get 2, -8. And now I start to see a pattern here. I'm going down 2 over 1. So I can go ahead and plot the rest of these points very carefully. I want to remember this is a dotted line. So I'm going to make it very clear it's dotted. And I don't want to forget to sign the line. The last thing I need to do is indicate where my solution is. Well, my solution is where both shaded areas are. So if I go up here, let me make this 10. I can see both shaded areas are kind of this magenta area over here. So my solution has got to be labeled with an S. And I'm going to go ahead and shade it so that it's really clear that all the points in this piece of the graph are part of the solution. The last thing it says is state the coordinates of a point that satisfies both inequalities. Justify your answer. Well, when it says justify, you can show work or a graph. So you don't have to write a complete sentence. So I want to pick a point that satisfies both inequalities. Be very careful. Do not pick the point where they intersect. That is not a solution because it's on a dotted line. Also, please don't pick a point that's really close to the dotted line. Pick something that is really obviously in your solution set. The point I picked was right here. And I drew an arrow. I said my point, its coordinates were -9, 1. So I knew -9, 1. I stated the coordinates of a point. To justify my answer, I said C graph. Okay, that's the first 6 questions. Tomorrow, there'll be a video for the next 6. Thanks so much.